Today we're going to review some statistics topics like mean, median, mode, range. I don't know that you guys have heard about standard deviation before. We're going to talk briefly about standard deviation, and we're also going to look at some basic matrix operations. But we're not just going to do this like we typically would learn this. We're going to view this as we might see it on the ACT. So this is some stuff that you might need for the ACT, and then if you look further in this packet, there are ACT questions at the back of this that will be your assignment. So first thing we need to talk about is an outlier. An outlier is a data point that is far removed from the rest of the data. So I'm going to put data point. Far removed from the bulk of the data. The mean is the average of the data. You find the average of the data by adding the numbers together and dividing by the number of numbers. The median is the middle number. You have to put the numbers in order from smallest to largest, and then the number that falls perfectly in the middle, that is the median number. The mode is the most, the data value that occurs most frequently. Those three are called measures of central tendency. They're measures of the center of the data. Now, if you remove an outlier, if the outlier was bigger than the data, it would shift those measures of center lower because you're taking a big number out. If the outlier is smaller than the rest of the data and you remove it, it would shift those measures of center up. Which of those do you think would be the least affected by removing an outlier? If we removed an outlier, the mean would be affected the most, and the mode would be affected the least. So the mean would be the most affected, and the mean would be the least affected by removing an outlier from the data. The next two things we're going to talk about are measures of dispersion, which is a fancy way of saying how spread out the data is. The range is the largest data value minus the smallest data value. If you've got a bunch of 2s and numbers all the way up to 10, 10 minus 2 is 8. That data would cover 8 numbers on the number line. If all of your numbers were between 2 and 5, that only covers 3 units on the number line. The more space you cover on the number line, that's more spread out. So if the range is large, it's more spread out. Standard deviation is another one that measures how spread out the data is. Standard deviation is defined as the average of the distance to the mean. So let's say I have these data values on a number line and I know that my mean is like right here. I would find out how far is this point from the mean, how far is this point from the mean, how far is this point from the mean, and this one, and this one, and this one, and this one, and I would take all of those lengths and then find the average of those lengths. So it's the average distance to the mean. And basically what you need to know about standard deviation is that a large standard deviation is more spread out. So if the ACT asks you a question like, which of the following data sets would have the greatest standard deviation? What they're asking for is which data set is the most spread out. And if range also tells you how spread out the data is, if the range would be large, the standard deviation would also be large. So take a look at these 4 data sets. Which one do you think is the most spread out? In A, we've got 2s, 3s, 4s, and 5s. That's all pretty clustered. 1 through 8, that's pretty clustered all around like 4. 2s and 20s, or all 7s. Which one looks the most spread out? Box and whisker plots are unique. It's a unique way to display data, and I honestly don't think the box and whisker plots get enough love. They're actually really cool. We're going to practice making a box and whisker plot, but first we need to put the numbers in order from smallest to largest. So pause the video, take a moment to write these numbers down in order from smallest to largest. Here's our data in order from smallest to largest. The minimum is the smallest number, 1. The maximum is the largest number, 9. The median is the number that falls perfectly in the middle. So take a moment and find your median. Q1 and Q3 are called quartiles. Q1 is the first quartile. The median is actually also called the second quartile, and Q3 is the third quartile. Basically, the median splits this into 2 pieces, the lower half of data and the upper half of data. Q1 is the median of the lower half of the data. So I'm going to take this lower half of the data. I'm going to use that median because our median is a specific data value. I'm going to use that median to help me find it. So between the 1 and that first 3, what is the median of just the lower half of the data? Two. We're going to do the same thing in the upper half of the data to get the third quartile. So, I don't know if you guys do what I do and count in with your fingers on either side. There we go. I got 4. Now we need to put this on a number line. When you draw a box and whisker plot, you are drawing it on a number line. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. The median is a line. So our median is 3, so above 3 I'm going to draw a line. The quartiles also are lines, so I'm going to put lines at 2 and 4. That forms the box of the box and whisker. So the left side of the box is the first quartile, the right side of the box is the third quartile, in the middle is the median. The minimum value we put as a dot and then connect it to the box with a whisker. The maximum value we put as a dot and connect it to the box with a whisker. Here's why box and whisker plots have tended to be difficult in the past. We are trained with all of the types of data displays that we use to think of space as meaning amount. A large amount of space means that there's a lot of stuff in that space. But here's the interesting thing about a box and whisker plot. From the minimum to the first quartile is 25% of the data. From the first quartile to the median is 25% of the data. From the median to the third quartile is 25% of the data. And from the third quartile to the maximum, that is also only 25% of the data. If we look at from 4 to 9, doesn't that look like a large amount of space? There's still only a quarter of the data in that space. So a box and whisker plot shows you how spread out the data is, because most of the data is really clustered from 1 to 4, and then from 4 to 9, the data is very spread out, but there's the same amount of data in each space. What percent of the data is between 1 and 2? 25%. What percent of the data is between 1 and 4? This chunk of the graph right here. What percent of the data is between 1 and 4? 75%. Because it's in such a small space, that tells you that that data is very, very clustered. It's very close to each other in that amount of space. Is there an outlier in this data? I'd say 9 is an outlier. With a box and whisker plot, if you see a big whisker, that probably means that there's an outlier, and that's why that data is so spread out. I want you to think for a moment about how would removing this outlier affect the mean, median, mode, and range. Now, we didn't find those values. We found the median, but we didn't find mean, mode, or range. But if I took this, where's my orange? So imagine that we took that 9 and removed it. How would it affect each of these values? So take a moment and think about that. Of these, the mean would have the biggest change, the range would definitely decrease, the mode would not change, and the median would only change a little bit because it would shift just one number either left or right. Okay, on your assignment, if we skip over the matrix for right now, on your assignment, these are actual ACT questions that have to do with statistics, mean, median, mode, range. So I want you to try those, do your best on those. You can help each other out. But then there's the matrices. The ACT loves to throw matrices on the test because they look hard, but if you've seen matrices before, they aren't hard. Here's how matrix addition goes. The 2 and the 5 get added together. The negative 5. What is 2 and negative 5? Negative 3. Then we do the 3 with, what number do you suppose we add 3 with? The negative 3. 3 and negative 3 is 0. The 5 is added to the 5. That gives us 10. And the negative 1 and the 4 are added together to give us 3. So on your own, add the other matrix. Okay. I want you to take a guess. For scalar matrix multiplication, what do you think we're going to do with that 2? Do you feel like maybe distributing it? So 2 times 3 is 6, 2 times negative 1 is negative 2, 2 times 4 is 8, and 2 times 2 is 4. Ta-da! Scalar multiplication. Try the next one. We're going to skip over matrix multiplication for right now because I want to show you how they combine matrix addition and scalar multiplication on the actual ACT. Go to number 17. This is a question that I pulled directly out of an ACT test. Given that A times the matrix equals this second matrix for some real number A, what is X plus Z? So we need to find X, we need to find Z. What we know is A times 6 is going to give us 27. So A times 6 is going to give us an answer of 27. We can divide both sides by 6 to figure out what A is. A happens to be 4.5. So then to find X, you would do 4.5 times 2, and that would give you X. So 4.5 times 2 is going to give you whatever X is. Then you could do 4.5 times 4, and that will give you Z. So 4.5 times 4, that's going to give us Z. Once you know what X and Z are, you can add those together to get your answer. So this just combines what we know about scalar multiplication. It honestly doesn't even have any addition in there. They want you to find X, find Z, and then add those numbers together. If you've never seen matrices before, you'd look at this problem and you'd say, I have no idea how to do that. You'd guess and you'd probably get it wrong. But this way you can at least get a correct answer. They typically put this question in the last 20 questions of the ACT. What do you guys know about the last 10 to 15 questions of the ACT? You're rushed and they're harder. The test gets harder as you go through it. So this is actually a pretty easy question that they tuck into the end of the math test to make you think that you don't know how to do it,